All right, today's lecture is going to be on water chemistry. Water's super important. If you take a look over here to the right, you can see that we've got an image of a water molecule. This big red or pinkish object is going to represent our oxygen, and the two small blue dots will represent our hydrogens. So water is the most abundant compound in living things. If you're looking at kind of trying to find an average, you're probably looking at 2/3 up to 80 or 90% of a living thing is going to be made up of water. So when you're taking a look at the actual atoms themselves, the little black dots here are going to represent electrons. And so if you notice for oxygen, we've got two electron shells. Okay, we've got our inner shell, which can hold up to 2 electrons, and then we have our outer shell for the oxygen, which can hold up to 8. Now, oxygen as an atom is only going to have 8 electrons, so it's going to have these two in the middle, 3, 4, 5, 6, and then one of these, and one of these would equal 7 and 8. For the hydrogen, if you notice, it's only got one shell, and it can hold up to 2 electrons, just like the oxygen's first shell can hold up to 2 electrons. But hydrogen actually has 1 electron on its own. So one of these would be for the hydrogen, one of these would be for the oxygen. Now if you notice, we've got these as a pair of electrons. Here's a pair of electrons as well. And what's actually happening here is that the electrons are being shared between the oxygen atom and the hydrogen atom. What's going to result from this is something we call a polar compound. So if you notice up here, we've got a positive charge, and down here we've got a negative charge, and this is because these electrons that are in this outer shell here are going to actually be spending more time with this oxygen atom. This is because oxygen is more electronegative. You can kind of think of it this way, is that the oxygen atom is a lot larger, and so these electrons, as they spin around this shell, are going to spend more time with the oxygen atom. On the other hand, since the hydrogen atoms are much smaller, the electrons, which are negatively charged, are going to be spending more time with the oxygen, less time with the hydrogen, therefore making the hydrogen end more positive. Now this polarity is going to lead to a lot of the properties that water have. And if you take a look over here, we've got 5 different water molecules, and they've got these little dotted lines in between. What these dotted lines are going to represent are something called hydrogen bonds. Now if you notice, this oxygen here in the middle is actually bonded to 4 other oxygen molecules, and that would be the same for every one of these water molecules. So if you notice here, hydrogen is bonded once, so we've got the positive hydrogen end, which would be binding to the negative oxygen end of an adjacent water molecule. So these hydrogen bonds lead to several properties of water, not the least of which is something called cohesion. Okay, so cohesion here, and if you look at the diagram, you can see that we've got 2 different water molecules being held together. Okay, and that's what cohesion is. It's where 2 like molecules are going to bind together. It also leads to something called adhesion, and if you look over here, you've got the water molecule bonding to something else. Okay, so adhesion is when molecules bond to unlike items. This would be the reason why you might see a meniscus in water inside of a graduated cylinder. So if you could imagine that this is a graduated cylinder here, and these are the sides of the graduated cylinder, okay, and if you kind of take a look and think of kind of a dip right here, okay, what this would mean is that the adhesive properties of the water and the glass in the graduated cylinder are stronger than the forces of the cohesive nature between 2 water molecules. When you guys do your water lab, you're going to see this in action. All right, so next we've got another thing that's going to happen because of these hydrogen bondings. And if you take a look, this is the meniscus that I was just mentioning here. This would be cohesive nature of water molecules bonding together. But again, the adhesive nature is leading to this inverted cup shape here in the tube. However, this also leads to something called capillary action or capillary attraction. And if you've ever put a small, say a drinking straw or maybe a coffee stirrer into a liquid, you will see that what will happen is the water will rise up into the capillary tube, in this case, but again, could be your straw. And this is showing you that the adhesion is kind of bringing this liquid up into the straw. All right. And then lastly, again, cohesion and adhesion. This is just going to kind of give you an idea of what's going on. So you've got cohesion, where you've got two like molecules together. Adhesion is two unlike molecules. And then the last thing here is surface tension that is created because of this. So notice these water molecules are binding together. Remember, that's going to be through hydrogen bonds. And this is what creates that surface tension. So if you've ever jumped into a body of water and not landed quite right, that's what's going to cause that painful feeling when you hit the surface. You're not just going to slide in. You're going to hit that surface, and it's going to feel like there's a solid surface in your way. All right, so here we have several different water molecules, and looking at hydrogen bonding, you can see how the hydrogen bonds are going to form between the water molecules. All right, notice here we've got our one water molecule bonded to 4. But if you remember, again, at this point here, these water molecules are taking up the area within this bluish square. But as the water molecules start to solidify, so you start to freeze the water molecules, they actually expand out and cause this set of water to take up a larger amount of space. So what happens when water expands and freezes is it takes up more space, meaning it becomes less dense. And this is the reason why frozen water, ice, will float on liquid water. It's kind of odd. Most other things are going to become more dense as they freeze. Okay, so water is also going to be good at regulating Earth's surface temperatures. It's going to carry heat around the globe. Think about the ocean currents. And this is going to be also due to the fact that water has high specific heat. It takes a lot of energy to heat water up. You probably noticed this whenever you've tried to boil water to make mac and cheese or something like that. But it also takes a long time for that heat to dissipate, which is why if you go into the swimming pool, say, in the morning, the water might feel relatively cool, okay, but as the day goes, the water heats up, and then in the evening, when the air temperature is cool again, the water is going to feel warm because it's holding on to that heat. It might not be until the next morning. Say if you're driving down Drumcastle and you see those ponds on the side of the road, and that heat is dissipating. All right, something else that happens with this water molecule, remember we talked about that it's polar. So if you look over here on the screen, we've got the green and black. This is going to represent our salt. So we've got our sodium and our chlorine. The sodium is going to be these little black dots. The chlorine is going to be represented by the big green circles. Then we've got our water molecules here. Remember, these water molecules are charged. So you've got the negative end on the oxygen, and then you're going to have a positive end on the hydrogen. And what it's going to do is it's going to actually dissolve this polar substance because it's going to be attracted to the opposite charges. So in this case, we've got our negative oxygens here that are surrounding sodium, and sodium is going to have a positive charge. And we've got our hydrogens, which remember those were the positive ends. Okay, they are going to be attracted to a chlorine atom, which is going to have a negative charge. All right, so this is why when you put salt into water, it dissolves because it's breaking up the sodium and the chlorine bonds, the ion bonds between those. All right, so the next thing, water is going to be important to many chemical reactions in living things. You're going to be thinking about things like dehydration synthesis and hydrolysis. In this case, we've got two sugar molecules. and we are going to put them together by removing some water. If you know, we've got H, and O, which is H2O. This process is called dehydration synthesis. So in order to build large molecules, we're going to have to use this process. If we want to break them down, we need water because we're going to have to add the water back in. In this case, we call this hydrolysis. Hydro means water. Lysis means to break. Okay, we will get into this in more detail in our next unit when we're talking about macromolecules. All right, so water can form mixtures. So we just talked about this. A compound is a chemical combination of materials that have a specific ratio of atoms. So water is a compound because it has 2 hydrogens and 1 oxygen. That is a specific amount. If you change either of those, you do not have water anymore. Okay. However, a mixture is going to be a physical combination. So notice the difference there. Compound, chemical, mixture, physical. And for this, we don't need to have a specific ratio of atoms. So, for example, if you go home and you make iced tea, all right, so you brew the tea on the stove, and then you pour it into the container and put water in. Well, whether I put it into a half-gallon container or a full-gallon container, I still have iced tea, right? The difference is going to be the amount of materials that I have in there. Okay, one's going to be a little bit stronger than the other. All right, so here's some examples of those types of mixtures. First, we have solutions, and then we have suspensions. So for solutions, this is where we're going to have things that are going to be dissolved. Okay, so we had our example earlier where we added salt to water. Okay, so the salt is going to be, in this case, something called a solute, okay, the thing that gets dissolved, and the water is going to be something called a solvent, which is the thing that does the dissolving. A suspension is going to have non-dissolved particles. So if you go down to the beach and you get a bucket of seawater, all right, you will probably pick up some sand as well. So the salt in the water is going to be a solution. However, the sand that you pick up in that water is going to be a suspension. So if you continue to agitate it, the sand particles will stay up in the water. However, if you stop the agitation, those sand particles, because they're more dense, they're heavier, they will fall out of suspension. All right, so let's go ahead and recap water chemistry. First, remember that water has a chemical formula of H2O. It is a compound because it has a specific ratio of atoms, hydrogen 2 to oxygen 1. Water is a polar molecule, so remember that water is polar because it's going to have an unequal sharing of electrons. You're going to have the oxygen, which has a negative charge because it has the electrons more often. It is a more electronegative atom, oxygen is. Okay, the hydrogens are going to be less electronegative. Okay, they're going to have a positive charge because they're not holding on to the electrons. Hydrogen bonding is going to be a super important property of water, all right, and it's going to lead to the other properties such as cohesion and adhesion that we spoke about. Cohesion, remember, is like connecting to like. Adhesion is like connecting to unlike. All right, it's an excellent solvent. A solvent is something that's going to dissolve some other material. Okay, water is actually the best solvent that we have. Okay, it actually dissolves more things than some of the strongest acids that you can think of. Okay, water has a high heat capacity. Remember, this helps in regulating Earth's surface temperatures. We talked about the ocean currents moving heat, through the oceans. All right, and then remember that water is going to be required for chemical reactions. We talked about dehydration synthesis and hydrolysis, which are 2 reaction types that we will also be speaking about in future lectures. So hope you guys learned something today. If you have any questions, feel free, email and or ask at the next lecture, and I'll see you then.